3, Lesson 26, the last lesson in Module 3. We're going to look at volume and surface area one more time with some real-world problems. So in our opening exercise, you're going to explain to your partner, or you should have explained to your partner, how you would calculate the area of the shaded region, and then actually calculate the area. This is very similar to the circle that we had quite a few lessons ago, where we had the outer circle and then an inner circle that was cut out. So what we're going to do is find the area of the outside, the larger rectangle, find the area of the inside rectangle, and subtract them. So our outer rectangle is 6 times 3, which is 18. And we'll subtract our inner rectangle, which is 5 times 2, which is 10. And so the area that is shaded will be 8 square centimeters. This is area, so it is squared. Example 1, we have a volume of a shell. Shell being an empty container. The insulated box is made from a large cube with a hollow inside that is a right rectangular prism with a square base. The figure at right is what the box looks like from above. So if we look down from the top, this is what it looks like. We need to calculate the volume of the outer box. So the volume of the outer box would be 18 times 24 times 21 1/4. No, I'm sorry, the dimensions are not right there. The outer box is a cube, so it's 24 by 24 by 24. And the volume of the outer box is 13,824 cubic centimeters. Then we're going to calculate the volume of the inner prism. And the inner prism is 18. It also has a square base, so 18 times 18, and its height is 21 1/4. And that volume is 6,885 cubic centimeters. Now we describe in words how we find the volume of the insulation. Well, we find the volume of the outer cube and then subtract the volume of the inner right rectangular prism, which is what we've already done quite a bit of work for. Okay, we're asked to calculate the volume of the insulation in cubic centimeters, and we've already done quite a bit of work for that. We have 13,824 minus 6,885, and that gives us 6,939 cubic centimeters. And then finally, we're asked to calculate the amount of water the box can hold in liters. So we have 6,939 cubic centimeters, and 1 cubic centimeter is 1 milliliter. So if we divide, because there are 1,000 milliliters in 1 liter, so if we then divide 6,939 by 1,000, we find that it holds 6 939 thousandths liters. In exercise 1, you're going to be designing a brick planter. You've been asked by your school to design a brick planter that will be used by classes to plant flowers. The planter will be built in the shape of a right rectangular prism with no bottom, so water and roots can access the ground beneath. The exterior dimensions are going to be 12 feet by 9 feet by 2.5 feet, and the bricks used to construct the planter are 6 inches long, 3.5 inches wide, and 2 inches high. We want to know what the interior dimensions of the planter will be if the thickness of the planter's walls is equal to the length of the bricks. All right, the first thing we need to do is to make sure that all of our dimensions are in the same units, because our dimensions of the whole planter are given in feet and the dimensions of the bricks are given in inches. So we first of all need to know 6 inches is equal to 1/2 of a foot. Three and 1/2 inches we're going to skip those other dimensions. They don't calculate very well, and hopefully we won't need them. So the interior dimensions of the planter, if the thickness of the planter's walls is equal to the length of the bricks. Interior dimensions. Our exterior dimensions are 12 feet. Okay, but then we have to account for the 1/2 foot on either side. That will be taken up by the bricks. So 1/2 foot on either side is 1 foot altogether. That means that we're going to have 11 on one side. On a second side, again, we'll have 1 foot taken off of that, so that side will be 8. And the 2.5 feet is how tall it is, so we won't worry about that yet. Actually, it has no bearing on it whatsoever, because there is no bottom. So the interior dimensions of the planter are 11 by 8. Next, I ask, what is the volume So our sentence then is, what is the volume of all the brick that forms the planter? And again, this is very similar to what we did here and what we did here. This would be our brick. We want to know what the volume of the brick is. So if we know the outside volume and we know the inside volume, we can find the difference between the two to find the volume of the brick. So we'll do 12 times 9 times 2.5. That's our outside volume, which is 270 cubic feet. And our inside volume, which is 11 times 8 times 2.5. And that is 220 cubic feet, sorry. And the difference between the two would be 50 cubic feet. So the volume of all the brick is 50 cubic feet. If you're going to fill the planter 3/4 full of soil, we need to know how much soil to purchase and what will be the height of the soil. So then we have a height, the original height is 2.5 feet. We need 3/4 of that. So we're going to multiply 3/4 times 2 1/2, which is 5 halves. And that is 15/8, which is 1 7/8 feet high. Okay, so then we determine the volume of the soil in the planter, and those are the interior measurements. So what we're going to do then is multiply the interior measurements, 11 by 8, and instead of 2 1/2, we're going to use 1 7/8, or 15/8. And that volume then is 165 cubic feet. Then we're asked how many bricks are needed to construct the planter. Now our bricks, remember, are 6 inches long, 3.5 inches wide, and 2 inches high. So first we need the perimeter. And our perimeter because there's going to be an overlap, we would have 8.5 feet on one side and 11.5 feet on the other side. So 2 times 11.5 plus 2 times 8.5 on the other side, which is 40 feet. Now why 11.5? Well, let's look back at this. The bricks are 6 inches long. So on each side, when you get to the corners, it's going to be reduced by 1/2 foot. So that's why our dimensions, each one is 1/2 foot smaller than the original dimension. So our perimeter then is 40 feet. From there, now we know from that perimeter that we are laying the bricks side by side, and each brick is 3 1/2 inches wide. So now we do actually need that calculation. 3 1/2 divided by 12 inches in each foot. And what we're going to find is 7/24 is a much better number than using a decimal. So 7/24 of a foot. And then we're going to divide 40 by 7/24. We can flip the second fraction and multiply. Remember all of that? And that would give us 960 over 7, which is approximately 137 and 1/10 bricks. And this is for one layer to go around the outside. Now, as it turns out, the brick are 2 inches high, and we need our planter to be 2.5 feet high. So we'll need to convert that as well. 2 inches divided by 12 in each foot is 1/6 of a foot. And we need, again, 2.5 feet. So we'll need to divide 2 1/2 or 5 halves by 1/6 of a foot. And again, the best way to do this is to flip and multiply. So we do then 5 halves times 6 over 1. And that will give us 30 over 2, or 15 layers of brick. 15 layers of brick. Once we know that, then we have 137 and 1/10 bricks per layer, and we need to multiply that by 15 layers. Which is going to give us approximately 2,057 and 1/10 brick. And of course, we would have to round up because we're not going to get 1/10 of a brick. So we're estimating then 2,058 brick. And we find that the bricks that are used in this project cost 82 cents each and weigh 4.5 pounds each. Supply company charges a delivery fee of $15 per whole ton. A ton is 2,000 pounds. For anything over 4,000 pounds. We want to know how much we're going to have to pay for the bricks, including delivery, to construct the planter. So we have 2,058 times 82 cents each for the brick. And we'll do that separately. Yeah, we better round up to 2,062. When you think about it, we might break a brick or two. So let's just round up to 2,060 times 82 cents per brick, which is $1,689.20. Then we need to calculate the tonnage. So we have 2,060 bricks times 4.5 pounds each. And that's going to be 9,270 pounds. And remember, we have to pay for anything over 4,000 pounds. So 9,270 minus 4,000 is going to be 5,270. And we'll need to pay $15 per whole ton over 4,000. So there are 2 whole tons, and they're not going to charge us for the extra after that. So 2 whole tons will be 2 times 15. That's an extra charge of $30. We add that onto the charge for the brick, and our grand total then will be $1,719.20 for the brick. But then, of course, we need to order topsoil as well. And a cubic foot of topsoil weighs between 75 and 100 pounds. We don't want to know how much the soil in the planter will weigh. So our minimum weight then will be 75 times 165. That's the volume of the soil in our planter. That was in part C. How much soil will you need to purchase? Oh, we didn't answer how high will the soil be. Oh, yes, we did. The height of the soil is going to be 1 7/8 feet. Okay. So our volume of soil is 165 cubic feet. So minimum weight would be 75 times 165, which is 12,375 pounds. And our maximum weight will be 100 times 165, which is 16,500 pounds. So the soil is going to weigh between 12,375 and 16,500 pounds. Yikes. Why does that matter? Well, if the topsoil costs 88 cents per each cubic foot, calculate the total cost of materials that would be used to construct the planter. So now we've got to calculate how much for the soil, and we use then 165 cubic feet times 88 cents per cubic foot, and that is $145.20. And then the total cost which was the cost of the bricks, the cost of the soil, was $1,719.20. The bricks plus $145.20 for the soil, for a grand total of $1,864.40. In the rest of lesson 26, you are going to design your own feeder. Given the information, you're going to go step by step in the same way that we worked through exercise 1. And then you have completed module 3.